The mechanics of inclusion and the inclusivity of mechanics is a cross-disciplinary effort between physics and engineering and a cross-institutional effort between Cal Poly, Allen Hancock College, and UC Santa Barbara. The overarching goal of this project is to eliminate equity gaps in performance in mechanics, specifically introductory physics, statics, and dynamics. Data show that ethnically and racially minoritized students and first-generation students have an average GPA as much as 0.5 points lower than their peers. We will focus on three main areas to address this. Number one, improving student performance in fundamental mechanics courses for all students. Number two, increasing student sense of belongingness and STEM identity development. And number three, developing and promoting research-based pedagogies that enhance active engagement and that cultivate a community of learners. We will develop a suite of adaptive web-based tools that incorporate videos that motivate why a topic is relevant to diverse professionals in the real world, and by creating interactive content videos, concept tests, instructional tools, and computerized adaptive testing. In the intro video, we will situate problems within authentic scientific and engineering contexts so that students see the relevance of what they learn to the needs of their communities, and also highlight contributions by non-traditional scientists and engineers so that students see themselves in these engineers. A second interactive content video would then introduce specific mechanics content similar to what would be used in a flipped classroom. Embedded in these videos will be 3 to 4 short comprehensive questions to help students process this content. Following the interactive content video, one or more targeted concept tests will be presented to the students to assess their understanding. Student responses to these concept tests will then direct them to an appropriate intervention. The intervention will confront the alternate conception elicited through the targeted concept tests and will differ depending on the student's answers. The next portion of the online module is the adaptive concept test. We plan to use our adaptive concept test to provide feedback to the students and as a formative assessment tool. Student performance on these concept tests might also indicate the need for them to return to the instructional video and/or the intervention to reattempt the learning module. Parallel to these online efforts will be the implementation of evidence-based practices in the face-to-face classroom, such as the integration of student learning assistants, implementation of hands-on, minds-on experiments, coaching the students on self-regulated learning, and helping them to develop metacognitive skills.
Hi, my name is Laura Rios. I'm an assistant professor in physics here at Cal Poly, and I'm going to briefly discuss how the Learning Lab is going to use learning assistants in their project. So a learning assistant, or LA, is different from a teaching assistant or a peer instructor in that their role is to facilitate discussion in active learning environments. To help better prepare them for this role, the LAs take a year-long course in pedagogy to help them better understand learning processes and also how they can support their peers and their students. The LA model is also distinct from other peer instructional models in that it really situates the LAs as orthogonal to the overall hierarchical structure of the classroom. The LAs facilitate discussions in what are called learning teams. Their role is purely facilitation of learning. In this way, students in the classroom tend to come to see their LAs as partners in the shared endeavor of learning. One hope we have and will continue to monitor throughout the project is that having LAs in classrooms will aid in normalizing the struggle that some students experience in mechanics courses in both the physics and engineering departments and really help foster that culture of community and teamwork.
One way to improve performance and success in STEM is through developing self-regulated learning and metacognitive skills. What we mean here by self-regulated learning or metacognitive things are not just skills that are discipline specific, but also general for problem solving and best practices in STEM settings. In other words, it's important that students learn how to learn. In this grant, what we're going to do is use a number of different interventions and learning activities to help students develop the skills they need to identify their strengths and weaknesses, spend their time more efficiently, study smarter, and articulate their understanding of fundamental concepts. We all seem to understand that when you can explain a concept to someone else, your understanding of that concept is stronger than if you cannot explain it to someone else. In this project, we'll leverage this idea to help students develop both the language and conceptual understanding needed for success in critical mechanics courses.
One of the exciting things about this project is that it will improve continuity between physics and engineering courses at each campus. In addition, lower division students taking equivalent courses at Allen Hancock and at Cal Poly will have more consistent educational experiences.
This grant project will provide us the opportunity to improve our in-class demos and help our students by improving the concept warehouse. As a result, our students will be more likely to succeed in their current classes as well as their future classes.
My name is Luis Herrera Delgado. I've been at Hancock since fall of 2017. I've taken all the physics and most of the engineering classes here. I really like Hancock because it's a very inclusive environment. The class sizes are a lot smaller, so I get to know my peers and instructors.
Over 50% of AHC students are Latinx, with a significant proportion of first-generation college students. We are poised to increase diversity in STEM and also improve the socioeconomic strength of our community.
With the diverse student population and strong cohort teaching at Allen Hancock College, the educational research and learning sciences expertise of UC Santa Barbara, and the learn by doing mentality at Cal Poly, we feel we can reduce the equity gap in mechanics courses and create a more inclusive environment in our classrooms.